Hello again. In our last video we introduced this notion of a linked list, which is going to prove to be one of the more important data structures that we learn about in computer science. And we have this abstract idea of a linked list, but we want to take a look at what exactly does a linked list look like in Java. So let's start that. Okay. What do linked lists look like in Java? Well, linked list consists of nodes, so the real question is, what does a node look like in Java? And the answer is that we're going to have some sort of class that represents a node. And what does a node class consist of? Well, let's see. We have probably a constructor, and the constructor is going to take in two things, right? A node stores two things, the data value and a reference to the next node. Therefore, when I construct a node, if this is how I indicate what the constructor looks like from the outside, it's going to take a data value and the next node. Now, what kind of thing is the data value? Well, it's going to depend. If I'm storing, it looks like here I was storing strings, so therefore when I define my node class, I would want the data to be a string value. When if I decide I want to store, I don't know, artichokes, then maybe my data value is going to be of type artichoke. Whatever it is I'm storing in my linked list. So a data value, and for now we'll make our data values strings. I think that will make life easier. And we'll also have a reference to the next node. What kind of thing is the next node going to be? It's going to be a node. It's going to be another node. So this is actually a recursive data structure in the sense that one of the two things a node remembers is a node. Okay, so it occurs to me this maybe looks kind of funny because I'm showing you this from the outside. All right, fine. We'll just implement the entire class. Here we go. Public class node. And I wanted to just write the API, but I think that's going to only confuse us. So, what does a node remember? A node remembers a data value, and that will be a string in this case, and a node remembers another node. Right, so one of the fields in a node is itself a node. Alright, and then this was our constructor. And I think you can guess what this constructor does, but we'll just fill it in here. That would be take the data value I am passed in and store it in the data field. So this is, if you're not sure whether you've seen this particular trick before, but this is take the data I'm passed in, so this is data the parameter, and store it in data the field. By writing this.data, I can tell it which data that I'm referring to, the data field and not the data parameter, which is the one I get by just writing data. Okay, anyway, let's not get too hung up on that. So take that data and next values that are passed in my constructor and store them away. And then I probably want some basic operations. Excuse me, basic operations. I want to be able to get the data, and that's going to return the data value. I want to be able to get the next node, and that's going to return that next node, which is again of type node. I want to be able to probably set the data, change the data value. Sure, let's just call it D this time, doesn't matter. So data, my field, gets the value of D, my parameter, and I want to be able to set the next to be a different node, right? If I want to change the linkages like we did up here, after creating the node, we want to change where it goes, we'll want this set next method that lets me change the linkage. So let's see, that's going to take the next field and store in it a reference to the node that I'm passed in. Okay, and there's the complete node class. But I don't want to get too bogged down on what the node class looks like. If you're comfortable with object-oriented programming in Java, and in particular defining classes in Java, then this should be, a pretty straightforward class, except for the fact that the type of the field matches the type of the class, which maybe you haven't seen before. But if you're not too comfortable with defining classes, it's not too important, because most of what we're going to do is going to be outside of the node class. So we're going to construct nodes, we're going to ask nodes for their data, and next, we're not going to have to worry too much about what goes on in the inside. So let's take a look at that. Suppose we do go ahead and let's clear that to, and we construct a node. So first I need a variable. I'll call it n. It will be of type node, and I will say n should refer to a brand new node, and if I remember, my constructor took in the data value, which is of type string, so maybe we'll say hello, because this is a very friendly node, and we need a reference to another node. So I'm going to assume that the variable another node already exists and already refers to some other node. And this may strike you as a circular problem, right? If every time you make a node you need some other node, well, how's that going to work? And we'll resolve that in just a second. So let's take a look at what a node might look like. I like to think of my objects in Java as being something like this. So here's a node object, and inside every node is, you know what, I'm going to draw a line because I think objects look good with lines. Inside every node is two things, a data value and a next. And we just said that the data value is going to be, hello, and the next, excuse me, the next was going to go to some other node that apparently already exists. And we don't know where that other node came from, but here's the beginning of it. We're not going to look inside, we don't really care. We do know that whatever that is, it has a data value and an x value, but let's not get hung up on what's inside it. So you see, I've only shown you the left half of this node. So the right half of this node will remain in mystery. But we do know that we have a variable called another node that apparently refers to this node. And the node that we just created, we're calling in. Okay, so here's what we did. We had originally this variable another node, and it referred to some sort of node. Now we've created a brand new node, that was this. It stores hello and a reference to that other node, and we've decided we're going to store that brand new node in our variable n. So this is the picture we have so far. So if we were to now ask n dot get data, we should get back hello. No surprise. If we say n dot get next, we should get back the something that is something that is equivalent to another node. In other words, get next should return the same reference that the variable another node returns. Which begs the question, what should get next return for the last node? What should get next return for the last node? If we ask the last, what is the next of the last node? What does that get next return for the last node? And if you think about it, there's only one thing the get next could possibly return for the last node. It's got to return something, and if it's a node, well, that would surprise us because we're supposed to represent the idea that this particular node, such as the go to class node, has no next. And if you have no next, but you have to return, get next does return a node, so that means that node object stores something in this next field. What can we store in the next field that is not actually a node? There's only one thing that Java lets us store in a variable of type node that isn't actually a node, and that is null. Null. So the null value must be returned by getNext, and that makes sense. So if we want to make the last node, we make a node and we pass as the next the value null. Okay, so that gives us a feel for the very, very basics of linked lists, or of nodes. I guess what we just learned was how to work with nodes. Now what we really want to know is, okay, but how do we work with linked lists? So we'll see that in the next video. I'll see you there.